now, sepatutnya kamu dah buat pasal for chapter 11. Betul? Dah siap belum? Pasal chapter 11. Nice.
Ada lagi yang belum siap, sir?
Ada lagi yang siap, tapi dah cuba buat lah. Okey tak? Banyak lagi ke? Mostly okey ke mostly tak okey?
Mostly okay, sir.
Okay. Ada certain benda yang kena ada jawapan tu ada lari sikit. Satu pasal unit dia, satu lagi jawapan dia. Nanti saya beritahu kot. Saya hantar kat WhatsApp. Anyway, for today, we're going to discuss chapter 10, which is about wave properties of a particle. Okay? And we're going to start with question number 7. So the question number 7, this is the latest one. Calculate the speed of a neutron with a de Broglie wavelength, 9 times 10 negative 11. So this is the information given. So based on the information, that one is actually your apa ni? Yang dah 10 kita sebelah apa sebenarnya?
Lambda, sir.
Yes, lambda. Good. Okay, so in this chapter, kalau kamu tengok, saya ambil tutorial. So if you want to refer to your formula sheet, there's a couple of formula for this chapter, which is equation 84, 85. I'm gonna write that one over here. I think previously I told you guys already that this chapter, it used to be a combination of more than one chapter. So not every year that they ask about this chapter. Ada certain ways dia tak tanya pun. So if you look at through your pasal, maybe ada yang lompong-lompong sedikit lah. Dia memang tak tanya. Okay, anyway, but for your syllabus dia memang akan tanya. So calculate the speed of wave, that's the speed of neutron with the de Broglie wavelength. So you are given neutron, which is basically a particle, which is what this chapter is about. Particle that behave like a wave that has a wavelength. Okay, which formula do you want to use? 84 or 85?
85.
84, sir.
Okay, dia cakap 84, dia cakap 85. So the question want to find the speed. The speed is actually equals to V lah kan? Soalannya nak V. So if you looking over here, jangan confuse dengan V ni. Ni sebenarnya adalah capital V. V over here actually represent the voltage. Okay. And since the question didn't say anything about the voltage, we have to use the equation 84. So if you are talking about energy, like I told you previously, this EV can be kinetic energy and it also can be E. But over here, we didn't talk about that. Instead, we are talking about this one. You can use this one. Of course, you can find the kinetic energy first, and then you can find the speed using half mv squared. But you need to have the mass, which we can get as well. So ada dua cara lah. But you want to do the simplest way. Okay, P here represent the momentum, which is equals to apa? P sama dengan apa? Momentum.
MV.
MV.
Okay, good. MV. P is equals to mv. So you need to use the mass of neutron over here because we're talking about the neutron. So, interesting. Okay, so it will be 9 times 10 negative 11 equals to 6.63 times 10 negative 34 divided by mass of neutron, which you can get from the constant of list of constant. Make sure you use the SI unit. So it will be 1.674 times 10 negative 24. Double check the question. Speed of neutron. So you have to use mass of neutron. 27, not 24. Okay, so dapat berapa ni? Over here is 4.4 times 10 to the power of 3. Did you get the same answer or not?
Yes, yes.
Sama sir.
Sama Okay. So I think maybe the given answer is wrong. So kita tukar. So it will be 4.4 times 10 to the power of 3. Saya tak tulis lah. Itu jawapan. Okay, question B. Calculate the wavelength of an electron that has been accelerated across a potential difference of 100 volt. Calculate the wavelength. So the question want to find the wavelength electron across potential difference of 100 volt. So basically you want to find lambda and you're given 100 volt tu apa?
Voltage.
Yes, voltage. So which formula do you want to use? 84 ke 85?
85.
Yes.
85
So
sir.
sangat straightforward So memang chapter ni straightforward lah. Sepatutnya tak masalah. Okay. Do it over here instead. So you're using lambda equals to h over square root of 2 and v. So since we are talking about electron, so the mass would be mass of electron, which is 9.11 times 10 negative 31. 1.6 times 10 negative 19. That one's for your E. And then V. Sorry, V is given, so you want to substitute V. we should get the answer, which is okay, dapat tak?
Dapat, sir.
Any question?
Tak ada.
Okay, tak ada. Okay, now maybe you can go to question 6. Okay, I'll give you a few minutes, maybe 2 minutes. Try to answer this one. Okay, so to answer this one, I think normally the marks will be 2 lah. Okay, the question states that one of the advantages of electron microscope is that we can see much finer details than optical microscope. Explain how this is possible. Okay, so the key thing about electron microscope is that you basically can control the lambda, and if you can control the lambda, you can basically control the resolving power.
Shorter the wavelength, sir.
Yes. Okay, so the wavelength, I can answer it like this, of the electrons can be much smaller than the saya agak terganggu sedikit sebab saya baru terima such a good news from one of my student. Anyway, so if you have this formula, if you have an increase in voltage, as long as you have a high voltage, you can basically produce a lower lambda. So maybe you can write the relation over here. Normally they give you marks for the relation. Okay, so from this equation you can answer the electron can be much smaller than visible light, since you can use this equation. And then maybe you can add on one more point where the ability or the resolving power, which is the ability to resolving power is directly proportional with the wavelength. So that means if you have not directly, then inversely. So basically, you can write oops. So as long as you have a shorter lambda, that means you have a higher resolving power. Okay, so this one is more like a theoretical question, but I'm not surprised if they will ask you in exam. So tak terkejut lah kalau dia tanya sebab dia memang possible. Dulu dia selalu tanya pun. Anyway, we're moving on to the next question. If you notice, just now we discussed 1819, 1718. So 1718 and 1819 is actually the one that is very similar to your syllabus lah. Memang syllabus yang sama. So this is the kind of question that they might ask. And suddenly it jumps to 2015, 2016. Okay, so in between maybe dia tak tanya pun. In between those year lah. Tapi that one is for the old syllabus. So yours dia wajib tanya. Okay, question number 5. In Davison-Germer experiment, an electron is accelerated from rest to a potential difference of 2,500 volts. Okay. And the diffraction pattern is observed on the tube screen. Calculate the de Broglie wavelength. Momentum of the electron increased to 3,000. What happened to diffraction pattern? Explain your answer. Okay. Cuba buat dulu. Try to think about it first. Okay. Saya kasi kamu maybe dalam 5 minutes. Jadi dia punya solution sangat similar with the first question yang kita buat tadi, question number 9 tu. Okay, so macam biasalah. The first thing kita keluarkan information. Okay, Davison-Germer experiment, if you guys still remember, dia adalah dia pakai electron gun and then they scattered on the surface of a nickel. And surprisingly, they produce a diffraction pattern. Okay, now, the potential difference 2,500 tu, that one is apa? Quantity apa?
V sir.
Yes. V voltage yang lebih besar. So that one is 2,500 volt. Calculate the de Broglie wavelength of electron. Okay, which formula that you want to use? Someone copy this one.
So H over MV.
Yeah. Which one? Yeah.
Yang 85 tu sir.
Okay. And we put it over here. So equation 84 tu we can expand a little bit. It becomes mv. Okay, tapi v ni since this one is a momentum, so this one is m mass multiplied with the velocity. But here they give you the potential difference. So you have to use the 85. Okay, it's like very neat. So equation 85. So you can use that one. So lambda is equals to H over 2 LEV. I think chapter ni kalau compare dengan chapter 11, this one is much more easier bagi saya lah. So 6.63. So mass of electron is 9.11 times 10 negative 31. We just double check that one. She's correct. Charge is 1.6 times 10 negative 19. And the voltage here is equals to 2500 volts. Okay, so now you just have to press your calculator. Make sure you calculate everything correctly. Be careful with the square root. So I've got over here is 2.46. Did everyone get the same answer with me?
Yes, sir.
Okay, good. Question B, calculate the momentum of electrons. So now you can use P equals to and V, but you don't have the V, so you have to use lambda equals to H over P. So basically your P now becomes H over lambda. Two point seven zero times 10 to the power of negative 23 kg ms minus 1. Mass multiplied with velocity. So you get this one. Okay, so normally the mistake will be from this one. Sometimes dia terlupa darab dengan E tu. Okay. And sometimes kalau ada unit dia kacau sikit kat sini. Satu, and then another one, students selalu confused between the V over here and the V over there. That one is common confusion lah about this chapter. Okay, the last question number 5C, if the potential difference is increased up to 3000, what happened to the diffraction pattern? Explain your answer. Apa jadi kalau kita increasekan dia punya voltage?
Wavelength dia panjang, sir.
Wavelength dia panjang. Macam okay, lepas tu apa jadi dia wavelength panjang? Katakanlah wavelength panjang. So I'm going to take this one. Okay, I think I'm going to put it over here as well. Okay, what will happen when you increase the voltage? So I think if you are referring to this formula, the direct
Wavelength
comparison,
shorter.
yes, the direct comparison between voltage and lambda. So wavelength is shorter, correct?
Inversely proportional ke sir?
So lambda is inversely proportional to voltage. Therefore, when voltage is increased, lambda is decreased. Sama tak? Kita buat arrow je. Tapi kamu jangan buat arrow je. Okay. When voltage is increased, lambda decrease. So bila lambda decrease, kalau kamu nak relate balik dengan velocity, so the pattern actually can relate with the velocity lah. So lambda is inversely proportional to the v. Since our lambda is decreasing, you would expect that the v will be increasing. I mean, you can skip the v part too, and then if you want to somehow relate with delta y equals to lambda gas, kita fikir formula lambda d over a. Formula ni dia tak nampak sangat. I mean, kamu tak boleh tunjuk formula. It's not appropriate lah kalau kamu tunjuk formula ni dekat sini sebab this one is basically a single sweeping diffraction. Tapi saya just nak kamu saya just nak remind kamu balik, if you have lower lambda, delta y kamu sebenarnya adalah decreasing. The decreasing maksudnya apa? Delta y decreasing, pattern tu becomes narrower ke wider? So the delta y here is actually spacing between the consecutive. Yes. So bukan narrower lah. So delta y tu distance between consecutive bright fringes. So patterns become narrower. Okay, but again, I'm not going to use this formula because that one is from different chapter altogether. But you can read it over here lah. See, lambda is decreasing. Therefore, pattern becomes narrower. So actually, you can relate with the single slit punya experiment. But that wouldn't be the appropriate formula. But it is enough for you just to say it over here lah, macam ni. So the marks will come from this one, you get 1 mark. And lambda is decreasing, you get 1 mark. So that should be enough. So as long as you ada state yang lambda is decreasing, pattern become narrower, you should get the full mark. Okay, that one is for question 5. Okay, maybe you can move on to question number 4. The question number 4 state the de Broglie relation for momentum. Also, the question want to state the de Broglie relation for momentum of a particle with associated wavelength. So apa? What is the de Broglie relation momentum with particle with wavelength? Apa dia punya relation tu?
Inversely proportional, sir.
Tapi this will state, so you can tulis dia punya formula terus lah. Tak ada masalah pun. Yang kamu cakap tu betul je, tak ada masalah. Okay, just to be on the safe side, just write where lambda is wavelength. Sometimes dia ada markah, sometimes dia tak ada markah. H is Planck constant. And P is the momentum. Okay. Now question B, 4B. An athlete of a mass 65 kg takes 12 seconds to finish a 100-meter race in a sports event. Calculate the de Broglie wavelength of the athlete. Okay, 65 kg tu is about saya punya berat lah. 12 second tu kalau saya lambat lagi lah. So lambda is equals to, okay, kau nak pakai formula apa?
84,
84, correct. So 84 tu just remember yang H over MV tu dia tak tulis, but then that one you should know it yourself. So dia akan kasih yang H over P, but we know that H over P is basically H over MV. So you're going to use the H over MV. The mass here is 65 kilogram. the velocity. Velocity you have to calculate, okay, because they did give you the distance, which is delta s over t. So this one back to chapter semester 1 lah. Anda buat apa? Oh betul lah. 1.22 times 10 negative 36. Meter. So the lambda is actually extremely small. Okay. Compared to light's punya lambda, which is negative 9 or something. So if you want to observe diffraction pattern for lights, you will expect a slit to be that in millimeter punya size. So this one, which is much smaller, if you want to see a diffraction pattern of this person, basically you need to have a very small slit, and you need to pass through it. So it's not possible to observe those pattern. Tapi this one dia ada dia punya lambda. Remember that. Okay. Okay, one more. So kita buat habis semua. Okay, question number 3. When a 546 nanometer light is used in photoelectric experiment. Okay, this one is more to a different chapter. Okay, so saya tak buat benda ni. Tapi bolehlah kita buat lah. This one kita cuba buat lah. Kita just a slide discussion on chapter sebelum ni juga. Chapter 9. So, macam saya cakap lah, dulu memang soalan dia mix up between chapter 9 dan chapter 10. Dia memang campurkan. Okay. So when the 546 nanometer light is used in photoelectric experiment, so kalau photoelectric experiment, the first thing that I ask you guys to do is to draw. Betul tak? Okay. Now you have to take out the information. The 546 represent yellow, black ke blue?
Yellow.
Yellow, sir.
Yellow. Okay, so that one is the lights coming in. 546 nanometer. The stopping potential is 0.3 V. That one is from black to blue to yellow.
Blue.
This now depends on apa? Stopping potential. Is it a constant for a material, or is it dependence on incoming incident light? Mana satu?
Depend on the indicator, but
Yes. So that one would be your EVS. So you can write, maybe I can write over here where K is equals to EVS. Salah pen. K is the kinetic energy of electron being ejected, equals to EV S. So we are given the Vs over here, which is equals to 0.38 volt. Okay, now calculate the work function of the matter. So we can use Einstein equation where E equals to work function plus the kinetic energy. In this case, you don't have the kinetic energy, but you have the stopping potential. So I rearrange, the B naught becomes E, which is HF. We don't have F, so I'm going to write HC over lambda. Minus with the kinetic energy, where this one now becomes EVS. Okay. So this one will be 6.63. It's going to be a long formula. Okay, I'm going to shoot it over there. We got over here 3.03 times 10 negative 19. Obviously, you can convert this one to EV, but the question did ask, I'm not gonna convert it. So I'm gonna leave it like this. Okay, question B, calculate the threshold of the wavelength. Sorry, calculate the threshold wavelength. B. So how do you want to calculate threshold wavelength? Saya pergi dekat formula. Oh, ini tak ada formula. I can write down the formula for this chapter. It is actually cover 1, 2, 3, 4. Banyak pula formula dia. Itu kat sini. Okay, equation 80, which is E equals to HF or HC over lambda 79, sorry, 81. Kalau banyak sangat lah, malah nak tulis. Okay, balik semula ke sini. Kita nak pakai formula apa? How do you want to find the threshold wavelength?
Pula.
Okay. Threshold wavelength tu datang kat mana? Dekat yellow ke? Dekat black ke? Dekat blue? Threshold.
Black.
Yes, dia datang daripada dekat material yang bawah ni. Okay, now, W0 that you calculated just now, this one represent value yellow, black, blue. Which one? Mana?
Yellow.
Okay. W0 actually adalah represent dia punya metal,
Black.
dia punya material. Yes, yang material kat bawah tu Isa. So, W0 is actually your information oops, over here. So, just now, you say that uh, I already write down the equation over here. So, since you have the W0, you can calculate the F0. F0 also represent the matter ataupun the surface to itself. So, F0 is equals to W0 over here. Make sure you use SI unit in joule because you have a constant, Planck constant over there. So as you guys notice, this question is not really straightforward. Okay, not straightforward. Just have to think a little bit. Soalannya nak bukan nak F0 ya. Soalnya lambda not, maafkan saya. Okay, lambda not. So this one will be HC over lambda not. So lambda not is equals to, I'm going to bring the lambda not over here and bring down the W naught. It will be HC over W naught. Cepat balik semua. Okay, my mistake. Now it becomes 203 times 10 negative 19. 6.63 times 10 negative 34. Okay, and then you have C. Jangan letak sini 31.5 pula. Okay, that one is for chapter 11 only. So I've got over here. Apa saya salah tekannya?
Terbalik.
Terbalik kan? Jadi HC over lambda. Okay. Nasib baik saya boleh angkat dia macam tu. So, kalau kamu dah tulis pakai pen, maafkan saya lah. Saya memang terganggu betul lah. So, sekedar saya tu dalam keadaan tidak stable, tak sihat. So, kalau kamu ada masa, doakan lah kawan kamu. So, 6.63, 34. Now the answer looks okay. So lambda naught is equal to 656.44 nanometer.
Dapat sir.
Dapat Okay. For the next question, question C. Calculate the minimum de Broglie wavelength of the electron. So now you want to relate with electron. Okay. The only information, so this one you answered already. The only information that you can relate is actually back to the question, which is this one. Okay, because just now you're calculating a different thing altogether. You're calculating W naught and lambda naught. So if you want to focus on the electron itself, you have the information of stopping potential there. So basically that was the potential. So I can solve this one using lambda equals to h over square root of 2 MeV. Okay. I need to use mass of electron, obviously. (1.6 times 10 negative 19). The voltage is 0.38. Alright. The lambda here sama dengan
1.99.
and laju 1.99 correct. Good, very good. So you got 1.99 times 10 negative 9, which is nanometer lah. Nanometer terus. Dua boleh diterima. Okay. Okay, and then we have two more questions. Question D. So C here is chapter 10. A and B is chapter 9. So D. Will the electron be emitted if the target material is replaced with a silver with a Fock function of 4.73? Okay, dia tanya sekarang ni, what will happen if you replace the metal over here? I'll copy this one. Let's replace it over here. Now, instead of having W naught with a previous value, they basically substitute W naught with 4.73 electron volt. Okay. So now you have to identify whether this one will it produce electron or not. Macam mana kamu nak check?
Kira.
Kira apa? Betul kira
Kira
tu kira apa? Ha?
Kira E.
Yes. Okay, dia ada banyak cara. You can calculate the E, the incident light yang datang ni. Okay, which I think we're gonna go to that method. So you can calculate function E ni. Sorry, values of E. And then we can compare lah. If E is bigger than W naught, that means electron will be ejected. I think this one is the simplest one. Okay. Tapi ada certain student, they maybe look at this question a little bit differently. You can use this information, okay, you can find the lambda naught. Okay, then you compare between this one and this one, which one is smaller and which one is bigger. If this one is smaller, electron will be ejected. Tapi cerita dia tu macam nak bayangkan susah sikit lah. So kita pergi yang senang sikit nak bayangkan. So we want to calculate the incident light. E equals to HC over lambda. Kita pernah kira ke sebelum ni? Tak ada kira. Tapi dia tak cakap. Sekejap saya kira. Okay. So kita tak ada kira apa-apa sebelum ni sebab E tu. So kita kira sekarang. 6.63 times 10 negative 34. C is 3 times 10 to the power of 8 divided by 546. So your energy should get an answer, but that one will be in joule. And if you want to compare it, you need to have the same unit. Okay, let's see if I convert this one to EV. So basically, I divide by 1.6 times 10 negative 19. Alternatively, you can convert W naught kepada joule. Mana pun boleh. Okay, I got here is 2.28 EV. So the incident light has energy of 2.28 EV. Okay, now back to the question. Does the electron being ejected or not?
No, sir.
No, okay. So the answer will be no. Since compared to the work function. Okay, so that's about it for question B. And question E, actually they ask you very similar question to the previous question that we answered just now. Okay, state one advantage of the electron microscope. So this one is actually back to chapter 9. What advantage the electron microscope compared to the optical microscope? What takes it better? So obviously electron microscope has high resolving power. The reason because you can control the lambda. Sama macam sebelum ni. Saya tak jawab lah, saya tak ulang lagi. Okay. Can refer to atas. Okay, you can refer to something similar to this lah. Salah. This one. You can refer to this one. Okay. Any question? So you can try to do the remaining question. Berarti saya soalan je, question satu tu. Ini cuba kamu buat. Ada soalan tak?
Tak ada, sir.
Okay, tak ada. Kita berhenti sini dulu. Okay, thank you everyone.
Thank you, sir.
Kita jumpa in our next class.
Thank you, sir. Bye, sir.
Okay, bye.
Thank you, sir.
Okay.
Selamat berkelas, sir.
Alright.
Thank you,
Okay.